Page 58, exponential notation. So we've seen this kind of thing a little bit. Let's expand x to the fourth. Well, that's just x times x times x times x. I have 4 x's here because of that 4 in the exponent. If I have x squared y cubed, I'll have 2 x's and 3 y's, just all multiply together. Number 3, this is a tricky one. X plus y, we call this quantity squared. If I want to square the entire expression of x plus y squared, we actually don't know how to do that yet, because this is just x plus y times x plus y, right? Squaring means multiplying by itself, and we don't yet know how to multiply binomials. We'll know soon. We'll learn soon, but for now, x plus y, if you're squaring that whole thing, you can write it out, but you cannot simplify it. And in particular, it does not equal x squared plus y squared. That is not the same thing. Example 4, x squared plus y cubed. If we're adding them together, well, they're different like terms. So we have something like this. Example 5. Negative a to the fourth. Order of operations says I need to do my exponent first. Take my a, write it out 4 times, then I tack on my negative sign. So this is negative a times a times a times a. If I had this though, add some parentheses. Well, parentheses trump everything, right? So order of operations says I'm going to take negative a and multiply it by itself 4 times. This is negative a times negative a times negative a times negative a. We've got an even number of negatives, and so it ends up being the same as, put this in parentheses, as a to the fourth. That looks confusing in parentheses. We'll just call it that. Okay, so we can also evaluate the following. If we have 5x cubed, if x equals 4, well, that's just 5 times, I need 3 4s multiplied together. I happen to know that 3 4s multiplied together, 4 cubed is 64. So this is 5 times 64, which is 320. If you don't happen to know that off the top of your head, you're welcome to use a calculator. What if we said 5x cubed if x equals negative 4? Well, I'm going to do pretty much the same thing. Now plug in the negative 4s. Take a moment and evaluate it. Pause if you need to. And hopefully you get negative, which example are we on? I forgot the parentheses. That changes everything. Okay, we'll continue with this example. This is fine. 5 times negative 4 times negative 4 times negative 4. That is negative, because we have an odd number of negatives. So that's negative 320. Let's look at example 3, which is what I meant to do. 5x, parentheses around that, and cube it. And let's say x is negative 4. Let's do something else for once. How about negative 5? Yeah, that's fine. Okay, so 5x cubed if x is negative 5. So I'm going to multiply this first. Take my 5 times my negative 5 before I start cubing anything. I have negative 25. Parentheses are still there, still very important. And I'm going to cube negative 25. When I do that, I know negative 25 squared is going to give me 625. Multiply 625 by 25, and you're going to get, I'll let you do that one. 625 times 25. I'm very tempted to do it, but you don't need to watch me try to figure that out. Oh, and don't forget, we've got a negative sign. So our answer is negative, whatever that is. I think it's 15,000 and change. Okay, moving on. Looking at a pattern, we have expanded form, which basically means just write it out. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have that. We could do 2 cubed, 2 squared. I'll let you fill in those. Go down to here, which is just a 2. 2 to the 0. Well, here, I'll tell you we get 16, 8, and 4. Divide by 2, divide by 2, divide by 2, divide by 2, because we have 1 fewer 2. So let's do it again. Divide by 2, we get 1. 2 to the 0 is 1. Divide by 2 again. 1/2. So we have 1 over 2. Now, square it, we have 1 over 2 2's. We get 1/4. So we're looking 2. There we go. And finally, we have 1/2 times 1/2 times 1/2. Because we're multiplying to the negative 3. That's going to be 1/8. You can do something similar with the tens. So looking at this, looking at what we've done above, let's look at some rules that we can conclude. We know that any number or variable raised to a power of 1, 2 to the 1, is just a number or variable itself. 5 to the first power, that's just saying take 5. Negative 7.2x to the first power is negative 7.2x. Any non-zero number or variable raised to a power of 0 is equal to 1. Not 0, it's equal to 1. Because basically we're saying I don't have anything to multiply. Let's multiply by the multiplicative identity, which is 1. 0 to the 0, we're not going to worry about. I'm going to say that's undefined and not argue about it. And number 4, for any non-zero number, n, and any integer, x. So remember integer, so we don't have a fraction or decimal part. N to the negative x is 1 over n to the x. We can throw this into the denominator at the cost of losing a negative sign. For example, 5 to the negative 2 is 1 over 5 squared, which is 1 over 5 times 5, 1 over 25. Okay. Let's go ahead and give a couple examples. I think I gave them verbally. But for number 1, something raised to the first power, let's say 3 to the first is 3. Let's say 3 to the 0 is 1. And now we have examples for each of those 3. And 0 to the 0 is the only thing that's quite like it. Or we could have multiple things to plug in. I'll let you think about how to do this one. And if you need to watch us do number 2 and come back to number 1, that's fine too. So if x is 12 and y is 6, remember you're just plugging in 12 for x, negative 6 for y. Here we just have x equals 6, so I'll plug that in. I have 6 to the negative 2 times 6 to the 0. I can do this a couple of ways once I learn some more rules, but for now, let's think about this. 6 to the 0, that's just 1. 6 to the negative 2, that's 1 over 6 squared. So I get 1 over 36 as my answer. Okay, so take a look, evaluate number 1. Pause if you need to, I'll give you the answer. Hopefully you get 9. That's what I got, and I'll meet you in the next video.